Welcome to TechBrothersIT. In this video, we are going to understand table partitioning in Azure Synapse Analytics, dedicated SQL pool. So if I will take you right here to the workspace and I'm on home page, then we will go to manage, and here is our dedicated SQL pool. You can see that we can pause or scale up or scale down, and all those kind of things can be done, or even delete. So if I go to the data tab here, that's where you're going to see this dedicated SQL pool database right here, and these are my serverless SQL pool databases. So there are two of them, but this is the third one. So we'll be creating the partition tables here in the dedicated SQL pool because serverless SQL pool does not support the tables. So there are no tables in this one. Okay, so what I have done, I have connected this dedicated SQL pool database to the SSMS SQL Server Management Studio. And how I have done that, I went to the portal.azure.com, then went to the Synapse workspace, and there is a dedicated SQL endpoint. So I copied this one, then I use this account to log into this dedicated pool. So here is my SSMS, and I went to connect, and in the connect I provided this endpoint. Here is the account, and then I provided the password, and then we end up here in the dedicated SQL pool database right there. So you can see tables and everything from there. Now in this case we are going to create a new tables. So why is the partitioning? Why exactly we do the table partitioning? So think about partitioning like dividing a very large book into the chapters. Instead of scanning the entire book, in this case we are talking about table, to find the information, you can go directly to the relevant chapter or the partition. So that's very helpful. So think about that. If you have a 400-page book and you divide into 4 chapters, and you don't need to scan from page 1 to all the way to the 400. If you divide into 4, maybe each partition will contain only 100 pages, and you can only working with one partition at a time. Now, improved performance. When you query your data using partitioning column, such as e.g. filtering by a date range, Synapse can scan only the partitions that contain the relevant data, skipping the rest. This is a significant reduction in the amount of data read or processed, making queries faster. This is called the partition elimination. So you understand that it is very much helpful to improve our performance because we don't have to read all the partitions. We can simply go to the partition that contains the data, and we can skip other partitions. Now, faster data management. Data loading, you can load new data such as data from the new month or a year into a separate empty table with the same schema and partition structure. So we call that as a staging table. Once loaded and validated, you can quickly switch the completed partition from the staging table into the main partitioned table. This is much faster than insert statement for large volumes. So let's say you have a table without partitioning and you are doing 1 million inserts. That's going to take a huge time. And then instead of that, you will write that data to the staging table, and then simply switch that whole staging table to the partition table, and that will be just even in seconds. So that's very fast. So you can the main table will stay as is. You are not making any inserts to that table, and you are doing all the processing or the cleaning and everything in the data in the staging table. And then once the data is ready, you can simply switch that staging table partition to the main table. Data deletion. You can quickly remove old data by simply dropping the entire partition instead of running a costly delete statement that has to log and remove individual rows. So this is also one of the fantastic feature. We can simply delete the entire partition in seconds instead of running delete statements to delete those rows from the partition. Easier management tasks like rebuilding indexing can sometimes be performed on individual partitions rather than the whole table, reducing a maintenance window. So if you don't need to rebuild indexes on the entire table and you need to rebuild only on the partition, you can do that as well. And I have shown you guys update stats and all those kind of things when you do on different partitions. So here are some range how we are going to divide the data into those partitions. So what is a right range versus a left range? That's we are going to talk about here. When you define partition boundaries, you specify the value that separate the partitions. You need to tell the system whether the boundary value itself belong to the partition before the boundary range left or partition after the boundary range right. So here is a more clear example. So let's say you define boundaries as value a, b, c. So if you are doing a range right for values a, b, c. Now, the boundaries values belong to the partition on the right side, the higher range, and it create partitions like this. So this is going to clear everything. So your partition A, so all values less than or equal to A. So partition 1 will have that. Then partition B, or actually second partition, all values greater than A and less than or equal to B, that will go in. And here partition 3, all values are greater than B and less than or equal to C will go in. And then your final partition 4, all values greater than C will go in partition 4. Okay, now let's talk about the range left for the values A, B, C, and the boundaries value belong to the partition on the left side, the low range. It creates partition like this. So for the partition 1, and it says all values are less than A. So you can see right here, all values less than or equal to A. So there is a slight change here. So it is everything less than A, here less than or equal to. And the same goes for the next ones too. So you can take a look. All values greater than or equal to A and less than B. And then for the third partition, all values greater than or equal to B and less than C, and all values are greater than or equal to C. And here you see that all values greater than C. So it is this one is also a little bit changing, including that value. So all values greater than and or equal to C. So see that it's an equal to C here, but here greater than C. So depends the whatever works for you. It is just a boundary that you want to define, and then once you will be able to define the boundary, then your all the data will go in those partitions. In this script we can use the range right. The partition function will place a row into the first partition for which partition column is less than or equal to the upper bound of the partition. The boundary values themselves define the upper limit inclusive for partition 1 through n-1 and lower limit exclusive for partitions 2 through n. The last boundary is the lower exclusive limit for the final partition. So you see that already in the example how exactly if you have value A, B, C, and how they are placed right here in the different partitions. Now let's take a more real-time problem when we are talking about the dates. So let's take a look at our boundaries. So let's say 2020 0101, 2021 0101, and then each year. So it is a yearly, and then January 1st. So you can see that using range right, these define the upper bounds. So except the last one is the lower bound. So you see right there, so you have this value your partition 1, so everything is less than equal to your 2020 0101, that will go in, and then you have this next partition, so where the value is greater than this value and less than or equal to the next year. So it keeps going in that direction, so you can see that it is a range. This is how the ranges are going to be for this dates. Okay, so now let's say if we go ahead and create this table, and what's going to happen, we are creating sales partition table, and we are checking if the table exists. So in case if the table exists, no, this table does not exist, so we are going to create this table, create table, table name, and then we say columns, different columns that we have, and this will be our partition column. So order date key, that's our partition column, and here we say with the distribution hash, and we are on the customer ID. So on the customer ID we are applying a hash algorithm, and then we say clustered column store index, that's our index, and here we are saying partition order date key and range right for values. You can see right there, so that's where we are providing our partition information. So and here you can see that we have a very first date 2020-0101, everything less than goes in the partition 1. See right there. And then we have 2021-0101, everything greater than 2020-0101 and less than this goes in the partition 2. So this value will range from here to this one. Will everything greater than 2020-0101 and less than equal to this value will go in this partitioners. And then again you have range here, everything starting from greater than this value, so and then ends with this value less than or equal to will go in this one. So you can see that. And last one is that everything greater than this value goes in this partition 6. Okay, so this partition table with the partition will be created. Let me execute this code, and now we have a table partition created. Okay, our table is created. What I'm going to do, I'm going to go ahead and insert some data. So you can see that row 1 we have 2020-0101 falls into the partition 1 as we have defined the range, right? So and then we have row 2 that 2022 falls into the partition 2. So you can see that I have changed the date key column values and then that's how they will be going to different partitions. So I'm putting everything right here. So let's insert the data. And now we can simply see the data in the table, and that will be, you are not going to see any difference here, like when you extract the data, like, hey, this is looking like partition 1 or partition 2 data. So you're not going to see major difference in the table, like select queries. So see right there, this is our sale ID, product ID, quantity, and sale date. So this is not really telling under the hood what's going on in which partition this record is or this record is. So to check that, there is a view I showed you in last time, like how to check the table size view, and this is a link for that one. I will put it in the description as well. So you can check the row count and partition number, and then from this view, and then I provided a table, and I'm checking if there is a row count is greater than 0. So I'm going to go ahead and execute, and this is going to give us information in which partition how many rows we have. So we can see that in the row count 1, and there is a partition number 2. So in partition 2 we have, see, there are 2 rows in partition number 2. There is 1 row in partition number 4, and then 1 row in 3 and 5. So in each partition is containing 1 row, but partition 2 has 2 rows. So you can see right there. Now think about that. Remember we were talking about, like, hey, you can load the data into the staging table and then switch into the main table. So this is our partition table. If you guys remember that, this is our partition table. And now here what I'm doing, I'm creating a staging table called sales fact stage, and then with the same keys and everything and same partition IDs, so range right for these values, and then I'm going to insert some records in that. So let's execute this table, and now we execute this table, and what we are doing here, now we are inserting some rows. So see, remember that in partition 2 we had only 2 rows when I ran this query, and you were able to see, like, right here when I executed this query, and it was telling us, I'm going to take this down a little bit so you can see right there. So our partition 2 has 2 rows. So see right there, 1 row. And now what I can do, I'm inserting this data into the staging, and this staging table has 3 rows. So you can see right there, this staging is going to have 3 rows. And then what I want to do, now I'm going to show you the data from the staging, and see right there, there are 3 rows for the staging. I want to take this staging table and put into the partition 2. So it's going to overwrite the partition 2. So in this case, I have a total, if I look into the partition table right now, I have 5 rows, and I know that there are 2 rows that belong to partition 2. So when I'm going to switch the staging table, so alter table, this is my stage table, and I'm saying switch partition 2 from the stage table and to the actual partition table, and replace the partition 2 in the partitioned table with the truncate target on. So partition 2 will be truncated in this partition table, and then whatever the data we have in stage partition 2, that will go to the partition the stage to partition the table. That's our destination. And once we do that, what's going to happen, right now our stage table has 3 records, and then those records will be deleted. So let's execute this one, and now you see that it's completed successfully. If I run this query again, and I should not see any record in this table, so the stage is empty because it is switched to the partition table, and the partition number was 2. So that's done. And if we query the actual partition table, now we should have 6 records. So you can see that we have 6 records. And if I will go ahead and execute this query, that will give me how many rows are in each of the partition, and then partition 2 should have 3 records. So see right there, this one, and then this one and this one. So this there are 3 rows in partition 2 because our staging table had 3 rows, and that has switched to the partition 2 to the our final table, and that 2 rows which were present in these partition table partition 2, they are gone, and they are overwritten by the our staging partition 2 data. So this is how you can actually switch in and switch out. You want to do that. What I will do, this is very helpful, and here is some more kind of notes. Both table must have exact same column defined data types, partitions and everything, and ranges. The partition number in the switch statement must correspond to the partition that we have already seen. That you can see right there, I have told like, hey, switch my partition to this, switch my partition to. So there are some notes. You are switching from to the 2, use the syspartition query to find the correct partition numbers. So always it's a good idea. Data must exist only in the source partition, that's in the stage table, and must fall within the bounds of the partition. And you guys have seen that we had inserted 3 records in the staging tables, and they were for the partition 2. So they were in between the boundary for partition 2, and then we were able to switch. So I will put this code in the description as well, and you can experiment from there. Thank you very much for watching. Please subscribe my channel, and I will see you guys in the next video.